Hello. Hello, am I audible?
Yes, you are.
Okay. Very good morning to one and all. Warm welcome to all the participants and our research speakers. So yesterday we had a great, wonderful session regarding our international webinar on forensic materials, and today we are waiting for the what we call it as busiest particular topic, that is what underground rail infrastructure. And I heartily welcome our today's speaker, that is Dr. Sri Priya Rengraju, who has completed her PhD graduate from IIT Madras, and her topic is underground urban rail infrastructure overview and construction. I really appreciate everyone's patience here now, because yesterday we had a great, wonderful interaction also. So today also I'm hoping for the best. Behalf of principal, behalf of J of Technology, I would like to welcome our today's speaker, that is Sri Priya Rengraju. Ma'am, you can continue, ma'am.
Thank you. Good morning, everyone. Just a second, I'll share my screen so that everybody can view. Yeah. Good morning, everyone. I'm Sri Priya. I'm a doctorate from IIT Madras. Today, I'm going to discuss about underground rail infrastructure, overview, and construction. So this is the brief outline of my presentation. First, I will give an overview about the underground metro, and a detailed discussion about diaphragm wall construction, where I was involved, and different quality checks that are being done in the site, the different challenges that are faced, and how to overcome those challenges. This is the alignment map of Chennai Metro. Here, there were two corridors in phase 1. In corridor 1, from Saidapet here to Washermanpet, the metro. So the different companies were involved in the construction, Afghans, Gaman, and L&T. And this Transnolstroy and Moss Metrostroy were the companies which had TBM machines. TBM is nothing but tunnel boring machines. So this phase 1 was mainly constructed to reduce the traffic congestion. You know that Chennai is a metropolitan city and had a lot of traffic that goes from North Chennai to South Chennai. So to reduce the traffic congestion and connect the north and time, this project was executed. So when I joined, some of the details of the project was given here. The project value was 918 crores. The project duration was estimated as 3.9 years. Estimated delay was 6 months. And they started the project in 2011. This is the bird's eye view of the underground metro. Here you can see that there is a station which are connected by the tunnel. The tunnel was constructed using the tunnel boring machine. The under was first constructed. They were all constructed as individual entities, and they were connected by a tunnel. Ends of the tunnel, you can see that the underground station is constructed like a bell mouth. This was done to receive the tunnel boring machine. So when the tunnel boring machine comes, the thrust has to be borne by the diaphragm wall. So here the wall has to undertake the thrust. So because of that, it was constructed like a bell mouth. So in this part of the wall, what they have done is they have used the FRP. instead of the normal steel reinforcement, because the FRP is polymer basically, so it can be easily drilled by the tunnel boring machine. So when I went there for the project, I involved in with Gammon India Limited. So they had contract packets UAE 02 to UAE 03. Here in UAE 02, you can see Government Estate, LIC, 1000 Lights. These three stations were there. And in UAE 3 contract, 4 stations, Gemini, Tenampet, Chamias Road, and Saidapet were there. So here you can see the different types of construction that was undertaken. For Government Estate and Saidapet, the construction was done by bottom-up approach, and all other stations had top-down approach. I will explain what is bottom-up and top-down in underground construction in the next slides. So this bottom-up approach is done when there is no space constraints. The site has a lot of space for handling the men, material, and equipment. In such cases, we go for bottom-up. But when you take places like Chennai, during the peak hours, you will face a lot of traffic in the areas like LIC, 1000 Road. This is basically the Anna Salai Road. So LIC, 1000 Lights, Gemini, Tenampet, Chemes Road, they were all just right beneath the existing road. So for these stations, top-down approach was adopted. For Government Estate and Saidapet, they had some space reserved for movement of materials. So there they had adopted bottom-up approach. So this is the cross section of the underground station. Here you can see the wall. This wall is called the Diaphragm Wall. This is nothing but a foundation which goes around the station. The station box is, I showed earlier, like it's like a bell mouth. So throughout the bell mouth, the diaphragm wall is constructed, and then in between it is supported by barrette piles. Barrette pile will go to the same depth of the diaphragm wall. Then you have a top slab which supports the existing traffic and the soil above. Then second is the concourse slab, which acts like a midway landing. Third is the base slab, which acts as a platform. So beneath the base slab, you have a lot of provisions for drainage, electricity, vibration control, etc. Here you can see two tunnels, because these underground stations were constructed as twin tunnel packages, one for upcoming and one for going up, below and above, like North Chennai, which connects from south to north, the upline and the downline. So these are constructed as two tunnel system. So whether you adopt top down or bottom up, the cross section remains the same. The way it is constructed, that only changes. So this is the top down approach. Here you can see that there is no place for handling the equipment. So all the things involved, like you can see that the reinforcement cage and other things. So you need space for handling of different kinds of equipments and the components involved during construction. And there should be also space for the crane movement in these places. So they adopt top-down approach. What they will do is they will construct the top slab. Here you are seeing a top slab. They will construct a top slab and they will have a excavation trench allowed in that is say 7 meter by 7 meter or something, where the excavator can go inside and dig from beneath. So from here, first the top slab is constructed, and through the excavation trench, the excavator is allowed to go down, and during excavation, simultaneously struts will be there to support, and then once they reach the level of the concourse slab, they will cast the slab, and again there also they will have the excavation trench, and from there they will send the excavator beneath, and then they will go till the base slab. So this is how the top-down approach is done. So since we are moving from top to down, and we have the existing traffic that is ongoing, you need to have that kind of structural support. The columns need to be strong enough to bear the overbearing load, and there will be a lot of piles that are drilled for supporting those columns. So you can, if you are not able to imagine how it is done, you can see the YouTube link. This is a beautiful animation that is given how top-down approach is done in underground. The next is bottom up. Bottom up you might have seen in several places, even in our foundation excavation in our buildings, normal residential buildings also, we will do a bottom up approach. What we will do is, we will excavate the whole area where we want to construct, and then we will construct according to the plan where there is no constraint. This is a side-up station. Here you can see that lot of space. You can see lot of cranes installed here, and the movement of men and material. Here you can see that excavated material are on the side for the carrying. So such kind of space is when that kind of space is available, you don't have to worry about anything. You just have to dig and construct as usual. But here also you have to be very careful, because when you are taking a large amount of soil from beneath. So the diaphragm wall, which has already constructed, here you can see that throughout this is the station. So throughout the box, it is kind of like bell it is constructed, and diaphragm wall is nothing but a retaining wall, kind of retaining wall. So when you are excavating, you should be aware of the pressure, soil pressure that is coming in the diaphragm wall. So to compensate that, you have to support the excavation so that it will not collapse or cave in. So you have lot of, here you can see that the different iron struts, beams, etc. So during excavation, they will support at each level, they will support the excavation by king post, and then with the girder. So the excavation is much easier compared to the top-down approach. So this is the construction of underground station. The several activities are listed. The first and foremost activity is diversion of utilities. So when you are going to construct beneath the existing road, you have lot of utilities. In India, there is almost no account for where there are underground lines going. There are a lot of underground lines like telephone lines, sewer lines, stormwater lines. So such kind of lines you have to identify first, and then divert from the alignment fixed. So there are a lot of departments involved. So you have to see what are the different things that are coming in your alignment line. Then the construction of diaphragm wall is done. I showed you it is done as throughout the station box. Once the diaphragm wall is done, in bottom-up approach, you will go to excavation and strutting. Then once you've done reach the base slab level, there are a lot of piles. Here you can see that there is a barrette pile which runs in between the diaphragm wall, like in between the station box. This supports the different slabs. Then the construction of base slab, concourse slab, and top slab are done. And in between the barrette piles, the slabs are supported by the shear wall construction. Once these are all done, then construction of entry and exit, like how we are going to move into the station and out of the station. That kind of structures are done. So this involves lot of activities and lot of teams. Here you can see that the cranes are there. Then there is a whole new different department for handling, and there is a different department for concreting. There is a different department for soil. All these teams have to work together to achieve the desired output, and this runs for several years. So this when they have such kind of activities to maintain the consistency, and if somebody is leaving from one activity to the other, what are the different things that are need to be done are all listed in a document called. So for each of the activities, there is a method statement produced. Okay, all the activities are documented, and it is given in in-depth detail. So this helps to achieve the quality and consistency throughout the project. So I will talk in depth with diaphragm wall, because when I went there, they were constructing this diaphragm wall. So diaphragm wall is about 26 to 30 meter deep. You can imagine the size of 3-story building. Nowadays, you can even imagine 4-story or 5-story, because the height of the roof is much lesser. So you can imagine that deep excavation. So during that excavation, what they will do is, first thing is they will fix the alignment, how the station box is going to be. Second, they will do a guide wall construction. I will go in depth what is each of the activity in the coming slides. First, I will list out the activity here. Okay. The next is trenching. Trenching is nothing but excavation. Third is, fourth is trench cleaning and in situ slurry test. So when you do the trenching, you have to see the trench is cleaned also. And then there is something called fixing of stop ends, which is followed by the reinforcement cage lowering, and then they will place the concrete, and then they will withdraw the stop ends. So this kind of sequencing will also help us to create a process, like from which contractor to which contractor it will move, and what are the different activities involved in the particular step. So this kind of knowledge will help us in execution and planning. The first one is guide wall construction. Here you can see the guide wall is constructed like through the whole station box is constructed as diaphragm panel. So each panel will last like 2 to 3 meters. And in that panel, first and foremost thing is, after fixing the alignment, they will do the guide wall construction. The guide wall construction is usually 1.2 to 1.5 meters depth, and here also there is a method statement involved, how much you have to dig, and how much you have to how to place the reinforcement cage, and what is the type of concrete that needs to be poured in, like that. All the things are given in the method statement. So once the guide wall is constructed, this acts like a guiding unit. So when the hydraulic grab or cutter that comes for excavation, this acts as a guiding unit and allows the grab or cutter to cut along the station box. There won't be any deviation from the planned structure. the alignment is fixed by the guide wall. Second, it prevents the cave-in of the topsoil, because there will be a lot of movement near to the topsoil, because of the handling of equipment, handling of cranes. So they need strong support. So this guide wall acts as a support and prevents the cave-in. And then the next thing is trenching. Trenching is, I already told you, trenching is nothing but excavation. So here you can see there are two different types of equipments involved. Here you can see the teeth. So this kind of equipment is done for, is used for excavation of soft clayey soil. So this is called hydraulic grab. So this grab will just excavate and leave the soil nearby. So when the clay soil is, you see that the soil profile will have first topsoil as a somewhat clayey soil, and then as you go deeper and deeper, there will be a hard rock encountered. So such kind of hard rock is cut by this cutter. So this cutter will rotate and it will try to cut the hard rock. So depending on the type of the soil profile, hydraulic grab or cutter is used for excavation. So you can see that this kind of equipment is used to dig around 26 to 30 meters. So such kind of deep excavation and this much narrow, you can see that the diaphragm wall is almost around you can say that 500 to 750 mm. It will be around something like that. So with this narrow excavation, so the 26 meter deep, how are you going to support such kind of excavation? Because when you dig deeper, the main problem with the deep excavation is caving in. You need to support. Otherwise, there are a lot of incidents during construction which caused cave-in and loss of men and in some cases machinery also. So how to avoid that? That is avoided by using something called drilling mud. What this drilling mud does is, the drilling mud will act, it's a viscous fluid which acts like a support for excavation. So what it will do is, we will pump the bentonite. Here in Chennai Metro, they used bentonite slurry. So the sodium bentonite was used as a drilling mud. So when you excavate, maximum the excavation length which can be supported by itself is around 1 meter or so. So when you go deeper and deeper, what they will do, they will pump this bentonite slurry inside the trench. So this is like a viscous fluid. It is basically a clay. Okay. So when you add clay to the water, what will happen? When you add, it will become very sticky. But when you add excess amount of water, it will become a slurry kind of thing. So that kind of slurry will have positive and negative ions, and that will go and act like a support medium. So if you imagine a paddy field, when it is dried, there will be a lot of flakes, no? So such kind of flakes will prevent the water seepage, and it will also act like a filter cake. So in fine grained soil, the bentonite will act as a filter cake, and in coarse grained soil, it will go and penetrate the sides and clogs the soil pores. So it has a dual purpose. One is the support the excavation trench. The next is it also prevents the water seepage from the adjacent areas. So it stabilizes the walls of the trench and ensures the overall stability. So when you use the bentonite slurry, you have to see the verticality of the D-wall also. Here, the vertical, when you excavate, you have to maintain the verticality of the D wall. This verticality is also tested by something called cordon test. It is similar to the plumb bob. Here you can see that when you use the plumb bob in masonry, by visual observation, we will see whether it is vertical or not. In cordon, what we will do, there is an ultrasonic sensor which is sent inside the bentonite slurry, and as it moves down, it will produce and records the reflected waves. So the distance is all recorded. So here this equipment is connected with the recorder, and the ultrasonic pulse which is produced and received are traced back. So you can see the verticality in the graph that is generated. And once this is done, there is something called recirculation of bentonite slurry. So when you keep the bentonite as such, the bentonite, what will happen to the clay? Bentonite is clay, right? So when you keep the clay as such, the clay will start coagulating. It's kind of becoming more viscous. The similar thing happens here also. So the bentonite, before concreting, we have to ensure that the bentonite is cleaned and it is void of any kind of debris or anything. Because as you excavate, there will be a lot of small stones and other debris in the underground thing. So such kind of things should not be there. Because once you start concreting, then all the things will go inside and that will become a weak point. So you have to clean the excavation trench. How you have to clean is, you have to do a recirculation. So what they will do is, before concreting, they will give a fresh bentonite, and they will, on one side, they will pour the fresh bentonite. On the other side, they will take the already contaminated bentonite, which is like it would have some topsoil, sand, then other debris. So they will take it from the other side of the trench. So this kind of, when they take the bentonite slurry from the D wall, they have to ensure that this is cleaned again. So the top contaminated soil, some of them will be discarded, and some which is like only has some small impurities, then they will be sent to something called desander. Desander will, what it will do is, it will remove the sand particles, and then it will become like a fresh bentonite. So, but before reusing, they will check for the specifications. There are different types of tests that are done, and when the specifications are met, then only their bentonite slurry is reused. So some of the tests I have listed here, which are done in the site for bentonite. So the first one is mud balance. What they will do is, this is like a small, you can imagine like a sitar thing. So here they will pour the bentonite slurry in the bowl, and then they will adjust the bar, and then when the spirit level comes to the thing, you can see the reading. This reading is the specific gravity of the bentonite. The next test done is marsh funnel test. What they will do is, they will pour the bentonite in this marsh funnel and record the time. So this will have a correlation with the viscosity. Already there will be a graph. So with the time recorded, you can identify what is the viscosity of the bentonite. The third test done is free swell index. So what they will do, they will pour the bentonite slurry in a measuring jar, and they will leave the bentonite for some 16 to 24 hours, and then they will find the swelling, how much it swells. So they will find the swelling, and to the nearest reading, they will take that as a free swell index. And since I told you, the bentonite is kept as such, it will become a coagulate. It will coagulate and become a gel-like thing. So for testing that also, because of that property only, it is supporting the walls of the trench. So how much gel is forming, that is also tested before reusing. Next test is pH. pH is you can directly immerse a pH strip and find the color. This color you can match and you can find the pH level. Then I told you the sand content. Once it goes to the desander, they will remove all the sand, but you have to find out whether that much everything is removed or not, or how much is the contamination, like that. Such kind of thing is done by this sand content. Here there will be a mark for mud level, so till that level we will pour the bentonite, and then we will add water, and then we will vigorously shake it, and then we will filter it to the mesh, and we will do it for several times so that all the sand particles will be filtered in the mesh, and that much amount of the sand is reported as sand content of the bentonite. So once you do all the test and ensure the bentonite is fresh, then what you will do is you will do the fixing of stop ends. So this is something called stop end. Okay, this all runs throughout the depth of the diaphragm wall. So here you can see something like some white kind of strip. Here you cannot see that as a white thing, but the cream kind of line that goes, that is the water stopper. So it acts like a formwork for the diaphragm wall, and helps in maintaining the perfect geometry, because there won't be any sideway going, like there will be a panel, perfect panel that is created. And then it will also have waterproofing, because here you can see that there is a water stopper. So it also helps in waterproofing. Once all this trenching and formwork is done, the next thing is reinforcement cage lowering. So why we have to say about this step is, since it is 26 meters deep, what they will do, they will divide the panels into two segments, like cage 1 and cage 2. And in cage 1 also, you cannot handle 26 meter long reinforcement, right, in a single thing. So they will have cage A and cage B. So what they will do is, first they will lower the cage B, and then they will support it. Here you can see the guide wall. See, I told you this acts as a support system for handling of equipments. So here you can see that first the cage is lowered, and then it is supported, and then the next cage B is done. Then in situ they will weld, and then they will make it to 26 meters, and then they will lower the reinforcement cage. So once this reinforcement cage is done, the next step is obviously concreting. So since it is a deep excavation, it is something similar to underwater concreting. How we do underwater concreting? We will use a tremie concreting. Tremie concreting is nothing but there will be a lot of pipes connected to each other, and there will be a hopper. So like we will connect each pipe. Here there will be a lock system. So once they do the lock, it will form a continuous pipe. So as they pour the concrete, like for each layering, they will again take the tremie out and then remove one by one. This is how it is done. So you have to also remember that since it is underground and we are not seeing, we cannot directly pour all the concrete throughout the length of the throughout the depth of the D wall. We have to maintain certain speed so that the top is it's not. It has to, the concrete has to set and it has to support itself. So once this is done, mainly the semi concreting is done to prevent segregation, because we cannot throw it from the top. If we are throwing, it will segregate. So to avoid such kind of segregation and uniform spread of concrete, we are using this semi concreting. So when you do a concreting, obviously there are a lot of in-situ tests that are done, and it is a requirement by the contract also. So they will do slump test, temperature test, and they will cast cubes to see what is the compressive strength, and they will also cast cylinders and do a RCPT test from the RMC. So this is mainly done to ensure the quality of the RMC delivered. The final step is the withdrawal of stop-ends. What they will do once they construct the diaphragm wall, this is the sequence of construction. So they won't do one by one like this. So they will do in a staggering way. So here and here there will be a stop end, and then here and here there will be a stop end. So this acts like a support system for the next excavation. So if you consider one as the first sequence, so for the excavating in the second panel, this will act as a formwork. So once they excavate it fully, they will remove the stop end. With this, the construction of the first primary panel will be completed. So throughout the underground construction, underground station, the diaphragm wall panels are constructed. So that will act like a boundary line. So this, if you are not want to see how the animation is done each step, then you can visit this link. Here it is done beautifully how the diaphragm wall is constructed. So I also want to talk about some of the things that are done in mega projects. That is, first thing is auditing. There will be an internal audit once in 6 months by the contractor themselves, and there will be also our employer's representative audit. That is here in this case, that is Chennai Metro Rail Limited. So from there, they will the representatives will come and then do a audit. So this audit is like a high level thing, but we have a lot of activities. For example, I just explained you in detail what are the different activities involved in D-wall. So if you have such kind of activities, we have to test in each level. So that kind of each sub activity and task level, if you want to do, there is something called inspection and test plan. We will have before the start of the project, we will devise what are the different criteria we want to test and who are responsible for that. So this is executed with the help of inspection and test plan. And there are other types of performance monitoring were also done, that is external audits. Because it involves a huge lot of money, men, machinery, we have to ensure that everything is going in a smooth manner. And since it is underground, then there will be a lot of complaints from the public. Say somebody's house is getting some cracks or something, then they will complain, and then we have to check what is causing the crack in the nearby areas. So when such customer complaints are coming, then also they will do a audit. So I want to talk about the inspection and test plan. Here, I hope you are able to see the document. Anybody, are you able to see the document? Excuse me. I think I hope you are able to see the Word document here. So You can see the lot of activities are listed here. Preparation and methodology approval, and something like in the diaphragm wall, I just showed you, like the bentonite properties are tested, then how the verticality is done, fabrication, couplers, then water stopper, all these are done. And who is the, like, what is the specification and what specification, the, like, we have to check with, there should be a guideline and then we have to check against the guideline, no? So there is a specification, we will check against that specification, whether it is a contract specification or it is a technical specification. Contract specification is something which is specified explicitly in the tender document. Technical specification is something which is needed for the which is done by the contractor during the execution, and that has to be ensured to have the required strength. So what is the acceptance criteria and what are the different verifying documents? Then the frequency of testing, what is the frequency, like whether it is a start of the project or every panel or something like that. And then what are the different parties involved? So subcontractor, contractor, then general contractor, somebody like that. So there are different things like hold point. Hold point means they will stop the construction. Once it is getting approved, then only they can proceed further. That is called hold point. There is something called review. Review means they just have to see whether everything is according to the plan. There is one more thing called witness. Witnesses, they just have to be, there should be somebody to show that you have done it. So that is like a witness in the trial. In the occurrence of the activity, somebody from the contractor side, somebody from the subcontractor side, somebody from the general contractor side, like that, somebody should be there. Okay, so this kind of test plan ensures that it is done in a the quality is of utmost care, and it is done properly at in each stage. Okay, so when such kind of activities are done, so they will raise something called request for inspection. So this is something like what is the activity, who is the contractor, who is the client, something like that. They will fill this, and the person who is doing the review will also fill here what is his remarks, whether he has to do a rework or whether he can proceed. All that will be filled here. So even though there are a lot of process involved and quality are ensured, several challenges were faced during the project execution. So we'll see what are the different challenges and how that can be overcome in the next few slides. So as a state, like when I went there, what was the current state without any external influence? This productivity matrix was captured in a term called percentage plan complete. So when they do a scheduling, how much of the activities are planned and how much is the type of activities that are completed. So that is represented in a percentage. So I have monitored for 4 stations, and the average of each station is listed here. So here you can see in station 3, the average percentage plan complete was 23, which was very, very low. So what is the cause for such variability? It is because of the assumptions of planning. When they do scheduling and planning and scheduling in the office, they will think that everything will go smoothly. They want they didn't expect a lot of variability and constraints during the execution. So such assumption, like everything is according to the knowledge which we have, that assumption was wrong. So because of that, there was a lot of problems with the plant activity. And then once that kind of plan gap is identified, as we move from top to bottom, the deviation was more. So if we are not able to do a excavation for a single day, so that will start cascading. So it will, the gap between the scheduled and the actual work will start increasing. So this is the as is state when I went there. So to identify the problems and what are the different things we can do to overcome those, that was the main objective of my project when I went there. So the first challenge which was associated with time overrun. Time overrun in mega projects because will obviously lead to the cost overrun. Since it will go to several years, the inflation also will come into play, and it will eventually cost us more. So first we have to we have to diagnose what is causing the time overrun. Then identify the constraints. What are the different types of challenges that are there, and what are the what is the priority of each constraint? So if you might have heard about a Pareto role, Pareto analysis, 20% if you are taking care, then 80% will take care automatically by itself. So we have to prioritize what is the most important thing that is affecting the execution. Then for that activity, what is the root cause, and what is the action plan that can be taken to mitigate the problem. So we have to do this kind of analysis, and then come up with the work plan. So when we do a diagnosis of the site, what I found is 40% of the delay is caused by differing site conditions and machinery. So they didn't expect something in the site, but because of the wrong soil data given to them, they assumed certain things and ordered certain type of machinery. But when they actually entered the site and they did the execution, they found lot of variability than the knowledge which was shared to them. Then because of that, there were a lot of delay, and that caused poor site management and also improper planning in the sense, once you have some equipment or anything breakdown, you don't have an alternate plan for the resources. Like equipment, machinery is down, but men are there, so you have to plan for the some of the activities for the resources. So such kind of plan was not there, so there was improper planning. And then the third and major factor was utility diversion. I told you there are a lot of lines like sewer lines, telephone lines, something like that. So such kind of utility diversion also took a lot of time. First we'll talk about the equipment breakdown. So in equipment breakdown, what happens is it can be divided into two types. One is soil type, another one is equipment related. So since the soil exploration is done in the initial time, what happened was, during that they had just a second. Are you not able to see my screen? Sorry, I was. I think.
Yeah, now it's correct, ma'am.
Okay. Okay. So here is soil related. What they will do is, before the starting of the project, they will do something called soil exploration study. They will drill a borehole, and then from the borehole, they will trace the profile. What is the soft soil, hard soil, something like that. And then like every 500 meters or so, they will do this kind of drill hole. And then they will just trace the soil profile. When they gave the soil profile, what they gave was in some of the stations they gave like soft clayey soil. So the contractors, they ordered the equipments like hydraulic grab, and in a fixed contract manner. You cannot change the equipment in between. So when they did such kind of fixed contract with hydraulic grab for clayey soil, when they encountered hard rock soil, so when you use a wrong choice of equipment, you will face lot of breakdown. And these are like some of the machinery which was procured only for this purpose. In if you take in India, Chennai was like after Delhi Metro, Chennai Metro was constructed. So there were not lot of equipment or machinery which were already available for exchanging. So when there is a breakdown, the spare parts were also not available. So here you can see that in I have listed the breakdown of hours of a cutter. Even the cutter, which is specific for cutting the hard rock, had lot of breakdown. When they were handling the equipment also, they were not able to maintain the machine properly, and a lot of wear and tear happened, which caused further delay. So this kind of equipment breakdown was the major reason for the delay. But there was, since it was a fixed contract, they couldn't do anything. So then the next item was poor site management. This had something we had control over, because this is since equipment is fixed and it cannot be changed in between. The next step what we can do is we can do a better management. So the different types of delay in execution because of the poor management was analyzed using a fishbone analysis. So for example, if it is a rework, there is a lot of lack of communication, where to get the drawings, whom to approach when there is a delay. That kind of communication gap was always there. And when you are changing drawing, you have to get the approval from the consultant. So when there is a delay in that, when there is a no clear control of responsibilities, it caused further delay. And when the equipment is a breakdown, or when the equipment is not able to be mobilized, because it you see that this is in the congested area, so you cannot move the materials and men as you want. You have to do it during the off peak hours only. So some of the equipments will be there and some of the equipments won't be there. So this caused the further delay. And this involves a lot of team effort. So subcontractors, contractors, then general contractors, like that. So if they have if they don't have a proper communication between them, that also caused a delay. So such kind of things, when added one upon another, it caused further delay. So the third thing which caused is diversion of utilities. Here there are a lot of problems involved with the shifting of small temples. So in the roadside way, there are a lot of trees which are also worshipped as gods. So when you want to cut such kind of trees, the apart from taking the approval from the government authority, you have to see the public opinion also. Some of the places where the public opposed, they had to divert the line alignment little bit, so that they won't have any problem with the public, because we are constructing something for the public. So the public approval is also essential. So when this kind of public outrage is there for shifting, you will face a lot of delay in the diversion of utilities. And also you have to go to each and every department for approvals. So this also caused a lot of delay. So the major causes of delay are three things. One is improper choice of equipment. Second is improper planning. And then third is diversion of utilities. So how to overcome these challenges? When you are facing these challenges, there is something called lean philosophy. This was introduced by Toyota company. So this was done primarily to eliminate the waste. What they will do is they will do the implementation in 5 steps. First step is identification of value or waste. So the type of activity, whatever you are doing, whether it is adding value to the end goal or whether it is a waste. For example, if you have an inventory, you are taking from the inventory to the site, then that is like you are storing, and then from storage you are handling the equipment and transferring to the site. So that is a waste of time. So if you can eliminate that storage and handling and directly deliver whatever you need to the site, then you are eliminating a type of waste associated with the handling and storage. So such kind of process steps are identified in each of the activity involved in the construction. That is the first step. What is the value added, whether it is a waste or value? Then second is value stream. Value stream means you identify that this is not adding value to my project. So that kind of non-value added projects are eliminated. Third is when you eliminate the non-value thing, it will automatically create a sequence and it will create a flow. So we have to see that the flow is even. That is, it goes smoothly and there is no stoppage. Fourth is called pull logistic. What it will do is you are getting the men and machinery, materials, everything just on time. It is not like overproduction or it is there in the inventory for some time like that. It is just whenever it is just needed, that time you are getting at that the needed resources. That is called pull logistic. When you do all this, you are eliminating the waste, you are eliminating, you are creating a process and you are creating a flow, and this will automatically will create a process. That process will help us to do a continuous improvement. So when you do a continuous improvement, you are able to achieve a maximum productivity. That is the concept of lean. So there are different lean tools available. So you can implement the elimination of waste and standardization by different approaches. So you can do, for example, here I have listed some of them. For like if it is a standard work, what they will do, they will document all the standard practices, which are best practices. They will document, and from that best practices, they will try to continuously implement and improve so that the maximum productivity is achieved. And for Kanban means just in time, you are going to get the men, material and resources like that. So you have different types of lean tools. In that, I have implemented the last planner system in this project. So what is last planner system? I will just explain you in a minute. When we create when we start a project, we will do something called master plan. So master plan will give a type of activities and what are the different things involved, and gives the idea about the cash flow and the need for expertise. At what time I need what kind of expertise. Then a macro plan is done for identifying the men, material and machinery at different points of time, what are my requirement. And micro plan is for the execution. This is the 3 levels of planning in traditional plan. traditional planning system. But when we go to LPS, what we have to do, what they are doing is, there is something called look ahead plan and weekly work plan. So the look ahead plan is like 6 weeks, 3 to 6 weeks plan, and weekly plan is for the week. When they do this weekly plan, what they will do is, they will acquire the PPC metric, and why, if for example 50% is achieved and 50% is not achieved, why the 50% is not achieved, the reason for failure is also documented. From that, the feedback is given for the next week, so that the next week plan is improved, and this feedback is also given to the look ahead plan, and the look ahead plan is improved. So there is a continuous evolvement of the plan, and this helps in the better execution. So the benefits of last planner system is, there is a better reliability of planning, better coordination, improved scheduling control, and reduced time delay. And when there is a reduced time delay, automatically the indirect cost of the project is reduced. So this kind of last planner system I implemented in the site. So I took a look ahead plan of 3 weeks, and when I implemented the last planner system, it improved the percentage plan complete by 8%. So some may think that 8% is not a big deal, but when you are going to implement for the first time, there will be a lot of resistance. So that kind of resistance should be overcome for this to be successful. So some of the learnings from the LPS implementation is, there should be a continuous cooperation with the different entities involved. For example, contractors, subcontractors, owners, all of them should cooperate. Then only you can implement it successfully. And the concepts of the last planner system, it should be known to everyone involved, like from the top management to the site engineer. All of them should be aware of the principles, and the site engineer is the person who is involved in execution. So his feedback and his involvement is of utmost importance for the LPS system to be successful. So if he has to be there in the planning stage, he has to be given such kind of authority by the top management. So the top management should also understand the concepts of LPS, so that the top management will give the site engineer the necessary role to be played. Then there should be a clear line of control, like from whom to whom the activity goes, and if there is a problem, whom to approach. And when you do this LPS system, there is a continuous process. The process is evolving. So the improvement of the process should be done on a day-to-day basis. Then you should have a lot of patience dealing with it, because it has to be all of the team, they will be trained in a traditional way. So you have to train them to think differently, and you have to talk to different team partners. So such kind of awareness and patience should be there when you are doing this system. So when you are going for a mega project, you have to have different tools to enable you to control the time and cost overrun. So this is the learning from the project execution from the site. With this, I will end the presentation. These are the acknowledgements. This project I did when I was studying in Anna University during my master's. So I would like to thank the professors who supported me, Professor Samuel Knight and Dr. Vijaypriya, and Mr. Anand Kadiwal from Gammon. He was the general manager, and Mr. Manikandan, who was very, very supportive. He was the site engineer, and Mr. Kalyan Vaidyanathan, who taught me how to implement the lean principles in the site, and Mr. Pratap Reddy, my colleague, And last but not the least, Jain Institute of Technology for giving me the opportunity to share the knowledge. Thank you. Now I'll take some questions if you have any. Am I audible? Any questions?
If you have any questions, you can ask in the chat box. Participants can ask questions in the chat box.
I think either I was too clear or everything went above head. Nobody had questions.
Ma'am, actually one question is there from ma'am.
Yeah.
Its question is there, ma'am. Can you see in this chat box, ma'am?
Just a second.
Okay, there's somewhere.
Yeah, actually, I'm not able to see what is the question. Yeah, there are a lot of questions. Which one I should answer?
You can raise the hands.
Yeah, participant can raise your hands and we can unmute them. And if you have any doubts, you can clarify with ma'am.
Okay.
Actually, I just saw mentioning of M15. I never said it is M15 grade of concrete. It is M35 to M45 grade of concrete was used in the diaphragm wall construction for tunnel boring. When the tunnel boring was done for precast elements, it was M35. And for diaphragm wall, it is M45. So that is the grade of the concrete that was used for the construction.
Ma'am, if we use polymer slurry instead of bentonite, will flushing be required?
Whatever may be the type of drilling mud, what happens is during the excavation, there will be some contamination. So there will be some debris, there will be some cave-in. So such kind of external contamination will require recirculation and flushing. Yeah.
Ma'am, what was the workability used? Workability of the concrete? Because ma'am, since streamy concreting was used.
Yeah, you can see the slump test which they did. It is like almost self-compacted concrete. So workability is defined in many terms. You cannot simply measure just the slump, but it was done at the site. Slump was the first test to be done. So it was almost like self-compacted concrete. Yeah.
Yeah, next question. Lords.
Hello.
Yes.
Ma'am, regarding forensic experts, so what is the minimum qualification for that? So where we can go for that?
No, your question is not clear. Can you repeat it, please?
For forensic expert, so what is the minimum qualification?
That you have to talk to the yesterday's presenter. It should be.
Yes, ma'am. So yesterday I lost my connection and I'll ask a lot of questions, but there is no replies.
Yeah, I think the yesterday's presenter Savita can take that up that question in a later point of time. Yeah, you will be answered in a later point of time.
So actually, speaker was different and today's speaker is different. So we'll clarify the doubts, yesterday's doubt. Okay, Lords.
Yes.
Yeah. Next question, please. So those who want to answer.
Ma'am, can you explain the fixing of stop ends again?
Yeah.
That part.
Just a second. Just a second. I will go to the slide and.
Actually, those who want to ask question, they can raise their hands. Just we will unmute them. Participants.
So this is the stop end. What it will do is it will act like a formwork, and also this has some water stopper. So this water stopper will arrest the water seepage from the adjacent areas. Okay. So, but why only at the ends we need? Because it helps to maintain the geometry. This the width of the diaphragm wall is almost fixed. Okay. The length of the diaphragm wall, we have to maintain the panel in some length specified, so that the construction box, the station box which is constructed, has certain job. So to have that, this top end is done. So this is like the almost equal to the length of the diaphragm wall, and through the crane they will handle this and they will put it in the excavation trench. So both the ends of the panel will have this installed, and once the diaphragm wall construction, the concreting, everything is over and the concreting is set, the adjacent panel, when they will excavate, that time they will take the stop ends out. I hope I am clear this time.
Yes, ma'am. Ma'am, you mentioned about FRP usage. Can you please mention why FRP was used in that, and which type of FRP?
Which type of FRP? I'm not sure about that question, but FRP was used on the sites where the tunnel boring machine was coming, because if you use a normal reinforcement cage, it will take a lot of effort for the drilling to happen. FRP is like, it's a polymer, lightweight, and when you drill, it will be easily come out. So to ease the drilling of tunnel boring machine, the sites where the tunnel boring machines are expected to be received, there they use the FRP first. Here I showed you the reinforcement cage, right? In this, instead of steel, they used FRP where the tunnel boring machine was expected.
And ma'am, there were various companies like L&T and Gammon. What were their specific roles? L&T was used for TBM
No. TBM, there are two companies involved, that is Transtonalstroy and Moss Metrostroy. These were the two companies which dealt with TBM. The construction of the underground station box was executed by different companies. Like, for example, Afghans did the construction box and they had a joint venture with Transtonalstroy. The Transtonalstroy did the TBM for them, for the package. Like, if they have taken from, if you take government estate to Saidapet, there were two contracts involved, UAE 02 and 03. The construction of the station box was done by Gammon, and the tunnel boring part was done by the Moss Metrostroy.
And ma'am, what was the role of L&T in that?
L&T had one package for which is not underground, I suppose, and all the for example, in 1,000 lights, they had hired the equipment from L&T. L&T and Algurier was another company where the equipment is hired.
Okay, I hope so. All of you have understood the concept. Many thanks for addressing the questions, madam.
Thank you.
Okay, and on behalf of Generation of Technology, I would like to specially thank you for taking an opportunity and concluding the session, because even I can understand that I hope so there is early morning 6 a.m. right for you.
Yeah.
And there is a snowfall, and I think so 1 degree temperature, and in this also you have managed to have the wonderful session. And I hope so all of us, the participants, have got the good knowledge also here now. Since we are entering into a new growth phase because of this particular underground, there will be a lot of technical errors also, because underground excavation, the things will be there. So the methods which you have suggested, it will help for our participants, I hope so. And your enthusiasm is very contagious, and we hope that in coming days we'll have another session for our this one institute. Okay, and I also thank our association partners, VTU and ICI. I heartily thank our vice chancellor, registrar, sub registrar, and registrar evaluation for their continuous support. For their busiest schedule, they didn't attend the particular program, but their continuity support was always there for us. And I would like to special thank our coordinators, our organizing committee, faculty members, JSW, ICI, ACC partners. Those all have indirectly helped us a lot. And once again, I'm thanking our principal, beloved principal, for giving us an opportunity to conduct this international webinar. And in coming days, we'll have a lot of this thing webinars in coming future days also. Okay, so I hope so, Sri Priya, you also managed it very well. I give you 2 minutes to speak about anything, then we can conclude the session.
Yeah, thanks, Dr. Rahul. I think I have done enough justice for this opportunity. And,
obviously, it was great. It was great. I hope so. That is what our participants have enjoyed a lot. So that's why there were a lot of questions also. And what we do is that I request our participants, if you have any more questions also, you just drop a mail to us so that I can get connected with madam, and I will reply you within 1 or 2 days.
Yeah, sure. I would like to take up any questions, and I would also thank the Jain Institute of Technology once again for giving me this wonderful opportunity. And I wish you all the best. And thank you everyone for being present in this throughout the presentation. Thank you.
It's a pleasure. Okay, it's a really pleasure. And here I am saying that when I'm going to get the certificate, those all things, obviously you're going to get the certificate. Just fill the feedback form. Okay. When another, say, daily there will be 100 certificates which will be releasing. So you will be getting, okay, in next 2-3 days you are going to get it. Just go through the this one mail ID as well as the link you will be getting. If you didn't get it, just drop a mail. Then we will see that in 1 or 2 days we are going to get it. Okay. And so apart from this, if any questions are there, you have the numbers also, contact numbers also, anything, and feedback. Okay, we are waiting for the feedback. Whatever it the feedback it is, we need it. Okay, so just drop points, then we'll have the interaction with you people. Once again, Sri Priya, thank you so much. Okay, really we had a good time with you. Okay.